Okay, write inequalities for the given graphs. So we start at -7, so I put x, -7. When it goes to the right, it means it has to eat the x. Okay. x1, going to the left, this way it has to eat the number. It has to open to the number, and we need the line because it's filled in. Okay, number 3. I have -5 as the low, 2 as the high. So I put x, -5 on this side, and then +2 on this side. Okay, so we always eat the highest number, and then we eat the x, and then we put the lines in because the bars, the circles are filled. Okay, number 4, arrows are going apart, so we put x, -5, and x2. So when it travels that way, it has to eat the x. We put a line there. Goes this way, it has to eat the numbers, and we don't put a line, then we write the word or. Okay, next page. Solve the inequality, graph your solution, and label the graph. So this one we have x plus 3 less than or equal to 7. You're finding all possible values for x. Okay, so x is over here. It has one operation. It's a plus, so no times, no divide. So when I have plus and minus operations, the sign will not change. Okay, and I'll just subtract 3, x, and 4. The sign will flip if you have multiplying or dividing each side with a negative number, which we don't have multiplying or dividing at all, so the sign will stay. So we have 4, circle. And since it's eating the number, x can be all values this way. So x less than or equal to 4. Okay, number 6. 10 is greater than or equal to -2x. So we have x on this side. It has one operation, and it's a times. So when you have times or divide, you want to circle it. And then if you have times or divide by a negative there, you are going to switch the sign when you multiply or divide. We'll be dividing here because we have a times. So there's no plus or minus we have to undo. Okay, we go straight to division, but we're going to switch the sign. So when we take care of that operation, the sign switches. So we divide by -2, divide by -2, so we have -5 over here and x over here. So the critical value is -5. We circle, we fill it. Eats the x, so when it's eating the x, the graph is headed that way. And we just copy down. That's how you label it, is just to copy your solution. Okay, number 7, x divided by -7 is greater than 7. So I look on the side where the x is at, and the operation, there's only one number, so there's only one operation, and it's divided by, so I highlight the division. Okay, just like I would at times. See, I didn't highlight anything here because I didn't have that times divide. Okay, in that circle is the times and divide with a negative. It is, so you're going to have to switch when you take care of that operation. Now, there's no outside number to add or subtract, so I go straight into the switch, and we times each side by -7, because the opposite of divide is to times. So you have x, and 7 times -7 is -49. Okay, so -49 is your critical number. So I circle, I don't fill it, and it eats the numbers, so that takes the graph this way. Okay, number 9, we have 2x is greater than or equal to 3x plus 5. So I have one symbol, just one. I know it looks like a long thing, but you're not going to go with your table because there's just one symbol. Okay. So we have x on each side. Well, we got to take care of that problem. We're going to take out one of the x's through adding or subtracting property of equality. So I'm going to go with the 2x. So I'm going to subtract 2x. From the 3x. Now when you're adding and subtracting, we just line the same symbol. It will not switch. So over here you have -8. Now you have 1x plus 5. So there's two operations. You got a times and a plus. You always want to highlight times or divide. But this time the times is by a positive number, so the sign will not switch. We will keep the sign. Now before we take care of that operation, we have a 5 outside which we need to subtract. And the sign never switches when you add or subtract. So that's going to be negative 13, then 1 times x. Now again, the times is by a positive, so we will keep the sign the same, because when I divide each side, it's going to be by a positive. So we have x, negative 13. So 0, negative 13, circle, fill it, eats the number, so eating the number takes it this way. Okay, number 10, negative 3 is less than or equal to 3x plus 6, less than or equal to 9. You have 2 symbols, so that means you're going to want to make a table and put 2 separate problems on each side. So on one side, this first symbol, we have a negative 3 value here, and on this side we have the expression 3x plus 6. Over here, this inequality has a 9 value on the right, and then on this side you have 3x plus 6. We have 3x plus 6 less than or equal to 9. Okay, so, and we will need the number line at the end because these are inequality symbols, means less than and greater than. So this side, you have 2 values, you got a times 3 and a plus 6. The times is by a positive, so when we take care of that operation, we will be keeping the sign the same. So I have to take out my plus 6 first, okay? That's just minus 6, so the sign doesn't switch when you're minusing 6. That's negative 9, and we have 3 times x. Now it's time to take care of the times operation. But remember, we're going to keep the sign the same because it's a positive that we're going to be dividing by. So, divide by 3. Divide by 3, I have negative 3 on this side, x on this side. Now don't graph it till we find the other side. Same thing, a times 3 and a plus 6. The times operation is by a positive, so that will be keep the sign. So I take care of the outside, the sign won't flip. Then when I go to do the inside operation, the times, the sign will not flip either because it's by a positive. If that was a negative 3, I would switch that, but it's positive. So I subtract 6 and I get 3, and then 3 times x. 3 divided by 3 is 1, so we have negative 3 and positive 1. And now we got to get the graphs going. Eating the x, so that's this way. And now it's eating the numbers, so that would be this way. Okay, so they come together, so I put x, I put the low here, the high here. Then we eat the high, and we eat the x. Okay, number 11, we have 2x plus 3 is less than or equal to negative 3. 2x plus 1 is less than or equal to negative 3, or 7x is greater than or equal to 49. So I need another table. And on one side we have 2x plus 1 is less than or equal to negative 3. On the other side, we have 7x is greater than or equal to 49. Okay, so and I'm going to need the graph at the end. Okay, so on this side, we have a times 2 and a plus 1. So I always want to look at the times. That's a positive 2 times x, so I will be keeping the sign the same. Now I have the outside number I need to take out, and the inside is a keep, so keep the sign the same. So I minus 1 first. That's negative 4, and then I divide by 2. X, negative 4 divided by 2 is negative 2. Okay, here I just have one operation. It's times 7. Well, it's a times, but it's by a positive again, so that's a keep. Now, I don't have to add or subtract. I go straight inside and divide, but I'm going to keep the sign when I divide. Now, if that was a negative 7 times x, the symbol would switch. 49 divided by 7 is 7. So we have negative 2 and 7. We circle and fill, and then circle and fill. So with negative 2, it's eating the numbers, so that's this way. And then with the 7, it's eating the x. So that's an or, and you just label them separately. Okay, Okay, number 12, the absolute value of x minus 2 is greater than or equal to 6. Now, any absolute value, we're going to have a table because it's a compound inequality. You don't see two symbols, but there's about to be. Okay? Since we have the symbol, we'll have to graph at the end. So within the absolute value function, we have the expression x minus 2. Now, you replace the absolute value with d. So it's going to say d is greater than or equal to 6. D doesn't have any operations, so I have my absolute value of 6, but that could be 6 or negative 6, because absolute value is distance from 0 on a number line. Well, that could be over at 6, but you could also be at negative 6. Now, the inequality, I use the given inequality at the positive, but then I flip it on the negative. Okay? Now we solve it. Only operation you got is the minus 2, so there's no times or divide. You just need to add the 2. The sign never changes when you add and subtract. So plus 2, so you got x and 8. Then likewise here, again, you just add 2. The sign won't change because it's adding and subtracting. Automatic. Negative 6 plus 2 is negative 4. So you have positive 8 and negative 4. So we circle and fill, circle and fill. X and 8, it eats the x, so that's this way. X and negative 4, it eats the number, so that's this way. So 4, okay. There you have it. Okay, number 12. We have 2 times the absolute value of x plus 2 equals 4. Do not go like this. You can't do that. It's not a parentheses. You are still going to your table. You are still going to put the inside expression on each side of your table. And then you are going to replace the absolute value function with d. So you've got 2 times d equals 4. Well, you have to undo the times, so you're going to divide by 2. It's just an equals, so d equals 2. So now I have the number, it's going to be 2 and negative 2. Now we just have an equals, so I just put equals on each side, and I don't have to graph it then. Okay? So plus 2, you minus 2. 2 minus 2 is 0. And negative 2 minus 2 is negative 4. So those are the 2 possible values for x. We don't graph them though. Okay, number 14, we have the absolute value of 2x plus 2 minus 6 equals 4. Within the absolute value, we have the expression 2x plus 2. Now remove that, and we don't have to graph because it's just an equals. So we remove the absolute value function with d, but so it's going to say d minus 6 equals 14. Okay, so a minus 6 is like a plus negative 6, so we're just going to add 6 to each side to figure out what the d is. And it's 20. So you can be at 20 or negative 20, and it's just equals. So now x has 2 operations, got times 2 and plus 2, so highlight the times. You don't have to worry about keeping it or switching it because it's just an equals. But we have to minus the 2, then we have to divide by the 2. So it's going to be 18, 2 times x equals 18, then we divide each side by 2, and we have x and 9. Okay, and then the same thing is done over here. Minus the 2, divide by the 2. So 2 times x, negative 20 minus 2 is negative 22, then we divide by 2, x, and then negative 11. Okay, and the next side's blank. Now you have 3-story problems. I forgot to put something here. Make a rectangle LLWW. Sorry about forgetting that. Putting a fence around a rectangular garden, we have 250 feet of fence. The length of the garden is 50 feet. Write and solve an inequality that represents the possible widths of the garden in which the fence could fit. So you have means less than or equal, and that would be 250. Now, you're putting that feet of fence around the four sides of the garden. Well, there's two sides of length and two sides of width. So 2 times length plus 2 times width. Well, we need to replace one of the variables. Unfortunately, we have this 50. The length is 50, so L equals 50. So you put 50 in for L. Now, it was 2 times L. Well, now it's 2 times 50, and 2 times 50 needs to be calculated. It's 100. So we have 100 plus 2 times W is less than or equal to 250. Now we can solve for W. It's got a plus and a times. You highlight the times. Since it's a positive multiplier, when we undo that operation, we're going to keep the sign the same. So we do have to subtract the 100 where the sign won't change, and then I'll divide by the 2, but I'll be dividing by a positive, so the sign will not change there either. So I subtract 100, so that's 150, and then over here you got 2 times W. Then I divide each side by 2, and we have W and 75. So we circle, we fill, each a number, so that's this way. Okay, another thing I forgot on number 16, I forgot to write average up here because that's going to be a clue that I want written there. Okay, so now let's read it. My goal in health class is to average 94 on my tests. So far I've received 88, 100, and 98 on my tests. Write and solve an inequality that represents the possible scores I could receive on my next test and meet my goal. Okay, a goal means greater than or equal to, if you have to write an inequality. And the goal is 94. Now I come up here and write and try to find the average. We're not going to be able to find it, but we at least want to pretend that we are. So, how many tests? There, you see 3, but we're going to take 4, so that means we need 4 terms added on the top. We know 3 of them in plain sight. 88 plus 100 plus 98. I don't have the 4th term, so I write plus x. Okay, so we have x, and then the 3 numbers right there. So 88 plus 100 plus 98 is 286. So there's your simplified expression. X plus 286 divided by 4. Now we have plus and we have division. So you got, when you highlight the division, you got to highlight the whole thing. Okay? The division is by a positive, so that's keep the sign the same. Now we have to do this in a different order. We have to multiply by the 4 first. Then we'll subtract the 286. So times 4 gets rid of that divided by 4. And I've got x plus 286. Because when the whole side is the dividing, you got to undo the division first. Then 94 times 4 is 376. And then we undo the plus. And that's going to be 90. And you graph it. 0 and 90. So you circle, you fill it in. Each number, the letter goes this way. Okay, that's it. Now the next one. I forgot to write something here. I want you to put variation equals 0.005. Okay. Also, I want you to circle the word range. The desired length of a wooden tile is 17.5 inches. Desired width is 10.25 inches. There's an allowable variation of 5 thousandths to each dimension. Write inequalities that represent the range of each dimension. So a range, I make a number line, and each number line's got 3 points on it. Now in the middle is what the length and width are supposed to be. So the length is 17.5. The width is 10.25, but we can go above it and below it by a certain amount. We have to find the maximum and the minimum. So I take my 17.5 and I add and subtract the variation. Okay, so first I add to find the maximum value. 17.505 and then I subtract to find the lowest value, 17.495. So the circles are filled in because they can be equal to those values. You take out that and then you just connect them. Now remember to label it. So you got L, 17.495 on this side, 17.505 on this side. Eat the high, then you eat L. Okay. Now the width is the same process. We take our 10.25 and we add and subtract the 0.005. First I add 10.255, that's your maximum. Then you take your 10.25 and you subtract 0.005, 10.245. Circle fill, circle fill. You take out the middle and then W, put your minimum, and then you put your 10.255. So you eat the highest, then you eat W. That's it.